Hi, in a previous video we saw how we can do image stacking for astrophotography, and we have compared how we can use different software depending on the kind of astrophotography you are after, and also which kind of software you can have on your computer depending if you are a Windows user or a Mac user. And now it's time to go further and consider post-processing. So the idea is the same. We are going to see how different software that are available will perform, how easy they are to be used. And this is not a full tutorial for developing astrophotography imaging from A to Z. It's just to compare the different software and point out some differences. We will limit ourselves to deep sky astrophotography, and so some of the software I may describe here are not really suitable for, say, lunar and planetary imaging. Before going on, we should point out that we can group these editors into two big categories. The general purpose photography editor, like Photoshop, like Lightroom, like Gimp and Affinity Photo. And then we have the specific astrophotography packages like Astro Pixel Processor, StarTools, PixInsight. The advantage of the general purpose editor is that, of course, we can use it for normal photography, and in astrophotography we can use it for all kinds of astrophotography. So if you are after editing a star trails rather than a deep sky image or a lunar shot, you can edit those images using the same general purpose photographic editor like Photoshop. If you are on the specific astrophotography package, then some may have no tools for enhance or fully edit, let's say, lunar shot, because they are more on the deep sky astrophotography side. So we will see these kind of differences along with the video. The starting point is this image here. This is has been stacked with the Deep Sky Stacker, DSS. It's it's the stack of 28 images, each 3 minutes long, and this is the star field of the California Nebula. Now, as always the case with Deep Sky Stacker, the stacked image is completely dark. Basically, you can see only the stars, and this is not a problem. It's just how it is, and the details are there, but are hidden in the blackness of the sky. So the first step we should do for the editing, for the post-processing, is the histogram stretching, or is also called background extraction, because the goal of this technique is to extract from the dark background all the information, and the idea is to be able to turn this kind of image into an image like that, where we can see the California Nebula here, we can see a cluster there, we have stars with different colors, and we have faint nebulosity on the background. So this is, of course, this is a fully edited image. Now we will more focus on the histogram stretching, and let's see how we can do this kind of steps with let's start with general purpose editors, photographic editor. So the first editor you may have in your computer is Gimp. Gimp is a freeware alternative to Photoshop. It's been around for many years, and there is a huge community, so it is easy to find the information you need. So we can load our 16-bit TIFF file into Gimp. So I'm not really Gimp user, I'm more of a Photoshop user, and I found the interface a bit confusing, and also where I expect to find some command I don't find. For instance, in image I don't find nothing for the levels or the curves. All these settings are in the colors menu. So let's go to level. Now this is also quite different from how Photoshop show this dialog box to tune the level of the image. What you can see finally is the histogram, and is here. You see that all the information are crammed on the left side of the histogram. The peak is there and is very narrow, so that means that all information are compact in that area, and that area is in the black of the image. Now the purpose of histogram stretching is to bring this peak more to the middle tones and also to broaden it up. So what we can do, we take this middle cursor here and we slide towards the peak, and you see the image is getting brighter, and now we can see here some hints of color of the California nebula. So the idea is to go in step, not to overdo, so not to clip any data, not to make visible, to extract noise. We want to extract only the details. So let's work in step, a little bit at a time. So this is the first step of the stretching. This is because we are using level is linear stretching. So we go OK, and then again we call up from colors the level. Now you see the peak has moved from the left edge more to the middle one. We can now start to modify the black point for the image, something like so. So we bring it near to the peak on the left side, but without touching it, so that we don't clip any useful data. And then again we go to take the middle cursor and we bring next to the right edge of the peak. We can do that in step. We say OK, and now what you see is that the California nebula is really beginning to stand out from the background. Of course, the image is much more bright than what you would expect for a night sky. So we can do another iteration. So we go again color, level, and then we bring back the black point to try to get some reasonably dark sky, and then we can move there a bit. We can go back, and I say we can stop in there. So this is the linear part. You see now the nebula is very visible. You see also that some gradient appears, and that is due to light pollution during the imaging session, and so we need to take care of that. And before we do that, let's do some non-linear stretching, and we do that with curves. So we fire up the curves, and now we can tweak in a non-linear way the shadow, the darks, the middle tones, and the highlights and the lights. So we can, for instance, drop down a bit the dark, and then we can make a S-shape curve to add some contrast. So you see how more defined the California nebula is. So you can do something like that. And this is the stretched image. So now it's only about cosmetic. The first thing you want maybe to do is to even up the luminosity. Now the problem with Gimp is that there are no plugins or action tools or panels that are specific to astrophotography and then can help you to even up this field in few clicks. So you have to do it manually, and this is how you can do it. So to even up this gradient, probably there are many different ways. So I'm not a user of Gimp, so what I found, maybe not the most straightforward way, but one way is to duplicate the level. So you create a duplicate, I duplicate the level here, and then I add a mask to it, and it's, let's say, white. So you see here the mask that is white. Now we go to take the gradient tools, and we draw a gradient on the mask. We click OK to see. Now you see that the mask here has a black part that is where the new adjustments I will make of this layer will not be used, and then we have a white part where all the adjustments will take place. So in the black part you will see the layer that is below, and on the white part of the mask will let you see what I am about to do. So now that I have the mask with this kind of gradient, I can click again on the layer. So we are working on the image, we go to color, we go to level, and now we start to move this middle cursor in order to darken the image. So we are going on we are moving it on the right, and you see the image below this dialog box is changing, and the idea is that we are trying to even up the gradient. We don't want to go overboard, and so we have something. Sorry, so let's redo it. I didn't confirm. That's a difference between Gimp and Photoshop. So we can do something like this. We say OK, and this is a gradient. We have reduced the gradient a little bit, and you can do a better job with a more accurate mask and or use curves to try to even up. And then from here you just simply move to adjust the white balance and things like that. So this is basically the basic workflow you have to do with these general purposes photo editors, and because you don't have any other way to do a stretch than not acting on levels and curves in steps. So you see that it's fairly easy to do it with GIMP. The same goes for Affinity Photo, so I will not show how to do that in Affinity Photo, but I want to show yes, we can discharge the card. I want to show you how we can do that in Photoshop, and that is because Photoshop we can take advantage of some plugins and some action tools. So we load the image inside Photoshop, and as you see, as expected, the image is rather dark. So we go to Image, Adjustment, and we go to Level, and we redo the same story, and we move it a bit, not too much. Then we go again, Image, Adjustment, Levels, and you see the histogram. The peak of the histogram moved from the left edge, is going towards the middle tones. The California nebula is starting to appear. So here we go again, and then we do another iteration this time, just trying to fill in to move the black point. Now we start to expand the peak. Now we can do it another iteration if we want. Okay, now you see we have, after a few iterations, we have brought out the California nebula, but this time we have also the gradient. Now, of course, and we want to fix this gradient. So we can operate as we did in GIMP with the layers and adjustment layers and masks, or we can rely on a plugin that is called Gradient Exterminator. This is a commercial plugin that works for both for the Windows and the Mac version of Photoshop, and the price is quite steep. It's about $50, I think, and there is a trial version, so you can try it before to buy. But if you are going to use Photoshop a lot for astrophotography imaging, then I suggest you to buy, because it's really worth it. So how the plugin works is fairly simple. We have this image. Maybe we do first we do a curve, so a non-linear stretch. Let's complete our stretching. So we do something so, like so, and then a bit. Yeah, something like that. So now we want to even up the image. So to remove the gradient, we take the lasso tool, we select the area around our target. In this case, what I'm interested in is the California Nebula. And then we go to Filter, RC Astro Gradient Exterminator. Now this has some parameters, some options you can choose, the details, the strength, if you want or not to balance the background. So this is how you find the default setting, which they work fairly good in most of the time. So we just click OK, and we have basically even up the gradient in the image. We can deselect the image, and from there you can work to improve the colors and to improve contrast and things like that. So you see, Photoshop is a bit more flexible because there are some options. One thing we can also do is to try to be more analytic with setting the black point. So we can take the eyedropper tool and shift click on a part of the sky where there are no nebulosity and no stars. You see here the value for the different channels on that point. So if we want to set the black point for the sky, we call again the level, but this time we are going to adjust the black point individually for every channel, and we look at the numbers here because we want them to be around 35 or so. So something like so, 34 for the red, then we can go 34 for the green, then we can go the same for the blue. That's very quick adjustment. You can do in a more accurate way, but you see that now the colors, at least for the sky, are more natural, and from there we can zoom in and see if this red, you see that we have a bit of coma and a chromatic aberration here that gives this part of the image a reddish hint. So what we can do is to fire up the Adobe Camera Raw filter, and we can go to the lens, can zoom in, and we can tweak the defringe parameter for the purple in order to try to remove this purple color fringe from the star. You see now it's gone. So if we look back, if we go back to the image, this part is not reddish anymore. And then from here you can try to tweak the white balance in a very simple way. Maybe you want to click on the black, or you want to click on this part. Yeah, maybe something like that, and then you can further tweak by hand, and you can do this kind of noise reduction and everything. That's really simple. It's similar to what you would do in Lightroom to tweak an image. So we can go OK, and now you can do something else. You see that we have a lot of stars. So usually after stretching and tweaking your image, one crucial step is star reducing. So the idea is to make the stars less imposing on the image, so to shrink them. And we can call the actions, and we can get the actions from many different sets that deals with shrinking stars. For instance, from the astronomy tools, we have here an action that is called make star smaller. We can run it. It doesn't take long in principle. Now it's done. If we undo, then the effect of the action with action tools, with the astronomy tools, sorry, goes on a new layer, so that you can, this is with the action and this is before the action, so you can tweak the visibility of the layer of the action to see the effect. You see how the stars are less imposing, less brightness, and if you go a bit overboard, you can tweak, further tune the effect with the opacity of the layer. And there are many other actions that you can use to enhance the DSO, to lighten them and dim the stars, to noise reduction, to improve I don't know, soft color gradient removal, and you can edit completely the image from the histogram stretching to the final tweaks, cosmetic tweaks in Photoshop with ease. And so this is how you work with general purpose photo editor. So that would be Gimp, that would be Photoshop, could be Affinity Photo. What you cannot do is this kind of editing with Lightroom, but you can use Lightroom in a different way. So you could load the stacked image into Lightroom. This way you have you can organize it in collections and things like that, tag the image so that you can find it easily, and then call Photoshop from within Lightroom, do your editing, at least for the stretching, star reduction and stuff like that. And when you are at this point, if you are not comfortable to use layers and filters, you can go back to Lightroom. The edited photo will be imported automatically in Lightroom, and then you can finish your editing in Lightroom as you usually do for all your raw of normal photography. So now we move to the other category of imaging, that is of software, that is software specific to astrophotography. And there are two I want to show. One is StarTools. This is a commercial program, and there is a trial that you can use for life, but you can save. So you can use your trial to get really proficient with the program, and then when you are ready to go, you can buy it. It costs about $50 or something like that. Is also actively developed. So here in the welcome window, there is a quick start workflow you can follow, and this is pretty much what we are going to follow for this example. So we say OK, and now we have to open the image. When we open the image, we choose it, and then the program will ask us which kind of image this is. So if you, like me, your image was taken with a DSLR and was already stacked in DSSS and had some white balance applied to it, then you click here, the first option, and you move from there. Otherwise, you can choose other option depending on how you have, which kind of image you are feeding to StarTools. Now you see here the image is as usually rather dark. So the first step is to do an auto development. So this is a digital develop process, and what it does is to stretch the histogram and try to make you see all the details that are in the image. The image is not visually pleasant. It's very noisy, and the colors are off. There is a huge gradient there, but we don't care about that. What we want to see at this stage, we can zoom in a bit, is that here there are some edges to be trimmed. That is artifact from the stacking. So we just use, of course you can tweak all these parameters, but is not it's beyond the scope of this video, so we just use standard options and see where we go. So we keep the image. So I want really to show in this video how difficult or easy it is to start working with astrophotography imaging in the different software. So now we have this digital process image. Now, as I said, we need to trim the edges. So let's do something like so. Yeah, something like here. And so we keep this part. Now all the green area, it will be removed, and we will work only with the center part of the image, which has no this artifact which may mess up with the other steps. You can see that is not the quickest program of all, and it can take some time even to do trivial tasks like cropping the image. So this is the image after crop, and now we go to wipe, and this wipe is tries to remove the gradient and the vignetting from the image. So we can just do, and of course you can tweak a parameter like aggressiveness and where you want to and vignetting and how aggressive has to be the algorithm on the corner. And here you see on the bottom right there is a spinning wheel that until this is moving, then the program is still working, so don't start to mess around. Now okay, this is visually awful as image, but at least it seems to be even. There is no gradient anymore, so we keep it because what we wanted to remove, it seems to be gone. We will fix the color later. Okay, so you see that after we have applied the wipe, we went back to this image, and what you see is stars and hot pixels that then you need to remove. So we do again, after the cropping and the wiping, we do an auto develop or develop again, depending on what you want to do. If you want to fine-tune development, or you are okay with the basic one. So here it proposes you if you want to restretch the global image, or if you want to stretch just the image as it is. I go usually with this one. So now this is the image. We keep it. And okay, so now you can go with contrast, the convolution, sharpness, and do stuff like that, this kind of tweaking. We can go with color. We don't really care about dual fine editing now. Now you can choose different kind of color style and also emulation methods. And you can also saturate differently the bright part and the dark part of the image. So while you can tweak like that, just slide on the cursor to change the aggressiveness of the parameter, and you can also try, for instance, different LRGB method emulation like RGB ratio, and the idea is try to get more natural colors and something like so. So we keep it. Okay, now this is the image that we have worked on, and now what you could do is to stop tracking and to do some noise reduction. So one option is to stop this tracking feature and do the final noise reduction, stop the tracking without noise reduction. I tried. Okay, let's try it. It can be very long. So here you want to tweak a bit the grain size until you don't see clumps. So that is of course too much. So maybe we go with with a 4 pixel just to try. When we are ready, we do here there are different type of filter. You can choose whatever you want, median, noise. So maybe we go with median noise, this grain size, and then we click next, and here is initializing the process. You will see the progression, and it can take some time, so I will pause the video now, and I will come back once this is finished. Okay, so after 5 minutes or so the procedure is finished. Now is rendering the preview. Here you can see now there are different cursor and sliders you can modify to cover the different aspects of this noise reduction. And the interesting part is that when you click on the question mark, you have a small help and the explanation of what the parameter, what the slider do. So let's see when it's, so let's keep the image and let's move from there. So we are basically at the end of this workflow. Of course, you can do many other stuff, but this is how you basically, this is the basic workflow for your imaging. Now this is the image done. There is one step more. You see there is plenty of stars, and you may want to do well, you can repair the background to remove some noise and some hot pixel and stuff like that. But let's jump to the star shrink. So it tells you that you need to have a mask for the stars. So just click OK, go to mask, to the mask editor, select auto, stars. So that's just do that. So now it's creating the mask for the stars and is applying to the image and is doing this and it will do the star shrinking. So that will be equivalent to what we did in Photoshop with the actions from astronomy tools. So this is the mask that we can keep, and now this is the mask applied to the image. So you see in red where it is to be applied, and here how you can modify the mask. So you can increase the pixel and then the interaction, and every time you change this slider you have the preview that is rendering. And then of course you can change, different mode. You have the shrinking core, you have expand the core, so that will expand the core of the stars. You have tighten the star, which is another algorithm to just focus on the stars. Overall, well, we can see the image how it looks with tighten. We can go to shrink and see how it changes if you use the shrink algorithm, and then you can choose I like this more than tightening, so I decide to keep it. And basically this is an image that has been developed with StarTools, and we're using a very basic workflow. Is not the program is sometimes a bit confusing in the interfaces and in the steps, but since the trial is you can use it as long as you wish, it's worth it to give a look. And if you do a lot of astrophotography, deep sky imaging, then it may be worth it to do it if you don't want to move to a fully grown astrophotography package like the next one we are going to see right now. So StarTools is a nice option. It deals only with post-processing the image, not with stacking, and is not the fastest kid in town, but you can live with it if you are not in a hurry in editing your image. So the last software I want to show you is Astro Pixel Processor. This is my go-to choice for deep sky astrophotography imaging. It's a fully grown astrophotography package, and you can do from image calibration to stack to post-processing. Okay, so this is the interface. First things you have to do is to set a working directory, and we go where I have the demo image. Now here on the left part you see some tabs that have number. Those numbers basically define the workflow. So you move from the first tab, number 0, where you have some information, some parameters for reading the raw file and the fit file, to load all your imaging and calibration files, calibrate, analyze the stars, register the image, normalize the image, and then integrate to create the stack. Once you have created the stack, you go to the tab Tools for post-processing. Now, if you have already an image, like in our case, we do Other, we go to select the image, it is not a multi-channel image, it is not a multi-session image. So now the image has been loaded into the program. We can double click here to make it display on the central part of the interface. Now you see there is already some stretching that has been applied, and this is because we had here the digital development process that has been selected. So if you remove that, you will see the image as it is. This is only for visualization. So everything we are doing is not affecting the file until we save it. So by default, this digital development process is applied. You see that of all the different methods, the California Nebula is very nicely displayed. Of course, we have the gradient in luminosity, and here we have on this part we have different kind of automatic stretching, from a more gentle one like this one to a very aggressive ones. So you see here the effect, and what I usually like to do is something like so. I found it works nicely with my imaging, or a bit more conservative like 20 bg, 5 sigma, 0 base. You can anyway change this at every time, and you can also tweak them manually using some sliders. Now what I want to show is how easy it is to go. So you could save the image like that, but of course we want to clean up the image, and we have some very neat tools to do so. First of all, here we have light pollution. So we go to Tools tab and remove light pollution. Yes, we want to do it on the image that is loaded on the viewer. So first of all, here the background has been kind of neutralized. So you see the colors are much more natural. There's no that blue color cast that we had before. And now we want to remove the light pollution. The best things to do is just go around and click and drag to create some boxes that then the program will analyze, and the information will be used to remove the light pollution. So here you can put the box in different size in a regular fashion, or just try to cover all the interesting part of the image, like the corner, in the polluted part of the image, in the less polluted part of the image. You try to avoid to put this box over the nebulosity or the galaxy, and stuff like that. You want really to have only the sky. So when you are ready, you calculate, and then those information are used to remove light pollution and gradient from the image. Of course, more boxes means that it will take longer to do so, but you see that now has been the sky in the image is evenly brightened, so there is no light pollution or gradient anymore. I will not go into the meaning of yellow box, red box and green box. We just happy with it, so we can save the image. Okay, you can, for these intermediate steps, you can keep the same name that are proposed, use the same format, fit format, and now is saved. Now, so you can go and load directly this image if you screw up the next step, and this image is saved on your drive in the working directory. Now, we could be happy like that. There is another interesting stuff we can do, that is calibrating the star colors. So we do that. Yes, we do the image on the viewer. Now this is the same principle again. We select some boxes with the stars in it. Again, more boxes, more time consuming the program will become. Now, if your images come from a classical standard DSLR, I would suggest you to use as calibration mode the balance RGB, and now you can calculate. And now you see that is analyzing the stars in the different box, so it's analyzing the colors for the population of stars and try to put them on this straight line. You see before we have a wider distribution around the line of stars color. Now it's been basically all the stars have been corrected and they fall on this straight line, and so we can just save the image, again use the same name, again use the same format, and we will find this image saved in our working directory. So this is pretty much the basic development that you can do in few clicks in Astro Pixel Processor. You can tweak a bit saturation. You can click on the saturation here and then find the slider there that adds saturation. You see now the California nebula is much more, the color is much more saturated, and here you have a saturation threshold that will affect how much saturation is distributed in the image. Parts that fell below this threshold are not saturated, and the parts that are above the threshold are saturated. So this way, for instance, you can avoid to have the sky to get some color cast because you oversaturate the sky. So you can separate stars and DSO color from the classical black sky background. And you see here, for instance, we have two stars that are different colors and that are neatly represented here. The California nebula is, of course, red. Then you can increase a bit the contrast, and finally you can put some sharpening. And that is basically the image developed with the with the Astro Pixel processor. Now to save it, make sure that this stretch box is checked, and so we can save it. Now the program will use the name of the input image and will add this -st suffix to it, so that you can just avoid to rename it, or you can rename it as you want. What is important is to change the file format from FIT to TIFF, and then also leave this color profile as it is, but in TIFF image bitdepth, be careful and choose 16-bit so that you can edit in the best way your TIFF image in Lightroom or in Photoshop, depending where you want to use it next. So this is basically how you can post-process deep sky imaging. This software is my favorite one. It's commercial. It's available for Windows and for Linux, for Windows and for macOS. Sorry. There is a trial version that is 30 days. You can use it for 30 days. And after that you have to buy, and you can buy it as an owner, so 150 euro one-time purchase, or you can use a renter license that is 60 euro per year and allows you to always work with the latest version of the program, and so you don't have to rebuy it if a major version will be released in the future. So I'm personally going with this second with this second option, so I'm a renter owner, and this is pretty much what I wanted to show you, and I hope you enjoyed this video and you got an idea of what are the difference between the different software you can use in order to edit deep sky imaging. And with that, I thank you for watching and see you next time.